Hello student, after structural isomerism, then the second topic is stereoisomers. Stereoisomers is also stereoisomerism. In the case of stereoisomerism, what is the definition of stereoisomerism? Same molecular formula. The same for structural isomerism, same molecular formula, but in the case of structural isomerism, same molecular formula but different molecular structure, different structural formula. But in the case of stereoisomers, same molecular formula, same structural formula, but different spatial arrangement of atoms or groups. It means, now check these two structure, A and B on the same side, D on this side and this D on that side, D on upper side and D in lower side, and C is also same side. In the case of these structure, now there is a D in both the structure of D is different. Same structure formula I know, but the spatial arrangement of D is different. It means this type of example is stereoisomers. Now the classification of stereoisomers, there's a two types of stereoisomers. The first is a configurational and the second is a conformational. Configurational is a separable configuration, and conformational is non-separable. It means the configurational you also separate this type of structure. Now configurational, by physical and chemical, the separable is possible by physical and chemical technique, and non-separable is also by physical and chemical technique. Okay, now separable configurational also has two types. The first one is an enantiomer. What is enantiomer? The mirror image diagram is known as enantiomer, and enantiomer show optical isomerism. This is a last topic of this isomerism chapter, but focus on this diastereomers, non-mirror image. This type of structure does not show mirror image diagram, and these type of structure also show geometrical isomerism and optical isomerism. So only focus on geometrical isomerism because today's topic is geometrical isomerism. Okay, now how to find geometrical isomerism is also known as cis-trans isomerism. In your examination, the question is given ki what is the second name of geometrical isomerism? So you write cis-trans isomerism is known as geometrical isomerism. Okay, now in the case of geometrical isomerism, just check. It is geometrical isomerism only possible for double bonds compound, not for single bond compound. Okay, now suppose you have CS3 single bond CH, double bond CH, single bond CS3. Now what is the IUPAC name? Meth eth pro but 2-ene. Clear? Now focus on double bond compound. Okay, now there is a carbon double bond. Okay, now both the carbon have hydrogen and CS3. So now this carbon have hydrogen and CS3. Okay, and this carbon also have hydrogen and CS3. देखो, just is very important how to check कि this formula is a cis and that formula is a trans. If the atoms or groups on same side, if the atom or group on same side, it means this is a cis but 2-ene. If one atom or group is different, it means opposite direction, diagonal form. Hydrogen in diagonal form, CS3 is a diagonal form. It means this is a trans. Okay, trans is a more stable compound and cis is a more reactive compound. So you know very well reactivity is inversely proportional to stability. Trans is a more stable compound, cis is a more reactive compound. If the question is given ki this structure show how many isomers? The right answer is 0, because stable compound do not show any structure. Now this structure show how many isomerism? There is a two type, two structure, it means two isomerism. So now butene, butene show how many isomers? There is a two type isomer. The first is a cis butene and the second one is a trans butene. Clear? Clear 100%. Suppose you have another example, CS3 CH CS3 C double bond C, and there is a CS3 and both C contain chlorine group. Okay, now what is the IUPAC name? Method probute 2,3 dichlorobutene. Okay, the same for this structure. First you focus carbon carbon double bond, then after one side is Cl and one side is CS3, again one side is Cl and one side is CS3. So now Cl on same side, CS3 is the same side, it means this is a cis. And second, one group is changed. Okay, now suppose there is a CS3 and there is a Cl, and there is a Cl and there is a CS3. If you change both sides, the structures are same. अगर इधर से भी करोगे इधर से, तो it means the structure is same. So now CS3 is a diagonal and Cl is a diagonal form, it means this is a trans, which is more stable. Trans is a more stable and cis is a more reactive. Reactive compound show another structure, but trans compound do not show any structure because it is a more stable compound. Clear? Now suppose you have this type of structure, CH, then CH, and there is a C2H5. Okay, clear? Now first you focus C double bond C. One side is H and one side is CS3. One side is H and one side is C2H5. Okay, now in this type of structure also show geometrical isomerism. Only one groups are same. Suppose in this structure there are two groups are same. If one group are same, if one group is same, it means this is also show cis. And that side, just change one side of atoms or groups, C2H5 and there is a H. H on diagonal form, it means this is a trans. Clear? If one group is same, it means this is also show geometrical isomerism. Okay, now geometrical isomerism only possible for double bond. Why? Why? Okay, now suppose you have carbon carbon double bond, one side is H and one side is CS3, one side is H and one side is CS3. Clear? Okay, clear? You know very well this is a sigma, this is a pi bond, this is sigma bond. So it means pi bond is restricted rotation. Restricted rotation. There is no rotation in pi bond. Clear? There is no rotation in pi bond. Suppose there is a two type of structure, double bond is there, so you change the double bond, it means again he convert the same on the original structure. Okay, so just focus on double bond. Pi bond, it means there is a restricted rotation. Okay, clear? So it means pi bond does not change, it always found in the same position. Okay, so pi bond restricted rotation, and it is also geometrical isomerism only possible for pi bond type of compounds, yeah, double bond compounds. So pi bond or double bond restricted rotation. Clear? Clear 100%? Okay, okay. Now the next structure, देखो, double bond restricted rotation, pi bond restricted rotation. Clear? Okay. Now suppose again, suppose you have same C double bond C, again Cl, again H, again Cl, again H. So this is a cis isomers. Okay. Okay. Now, so you know very well this carbon have how many sigma bond? So this is pi sigma, 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 sigma. So this carbon show sp2 hybridization, and this carbon also show sp2 hybridization. So you know sp2 hybridization, this is triangular planar structure, या trigonal planar structure, trigonal या triangular planar structure. Triangular planar means it forms only plane of paper. Okay, all structures are, all atoms or compounds are present in plane of paper. The sp2 bond angle is 120 degree. Clear? The 120 degree angle present in sp2 hybridization, and sp is a 180 and sp3 is a 109.28. Already explained in my last video. Okay. Okay. Now suppose you have another structure CH3, CH, double bond CH, CH2 and then CH3. So just find कि this type of structure show geometrical isomerism. This is your homework. Now the next one, pen 2-ene. So pen 2-ene show geometrical isomerism or not? So just first you write down the structure CH3, then pen 2-ene CH, double bond CH, single bond CH2 and single bond CH3. Okay, the same structure is there, na? Yeah. So just this is all. This same question is there. Pen 2-ene 1, 2, 3, 4, 5. Same question. This is your homework. Okay. Okay. Now is very important information. Suppose you have this type of structure. Same one carbon attached to hydrogen and one carbon attached to CH3 group. This type of structures does not show GI. Why? GI means geometrical isomerism. If one carbon contain two CH3 group, it means this type of structure does not show geometrical isomerism because of this 2 CH3 is a bulkier group. Bulkier means heavy group. So maximum bulkier group is there, it means maximum repulsion is there. So this type of structure does not show geometrical isomerism. Clear? Now the next one again, but 2-ene 1,4 dioic acid. So just you write down but, how many carbon? 1, 2, 3 and 4. 1,4 dioic acid, it means there is a COOH, and 2-ene 1, 2, there is a double bond and one hydrogen and one hydrogen. Clear? So first you focus, there is a C double bond C, there is a one hydrogen and one COOH group, there is one hydrogen and one COOH group. Clear? So same hydrogen is there, same COOH group is there, it means cis. And the next structure is what? Trans. Clear? COOH and H. This is trans. Clear? Trans is more stable and cis is more reactive. Okay. So now if hydrogen on upper side, this type of structure is known as fumaric acid. So fumaric acid is a transform of fumaric acid, just wait, sorry, this is not a fumaric, this is a maleic acid. So maleic acid is a cis form of but 2-ene 1,4 dioic acid, and trans structure is a fumaric acid. So fumaric acid is a transform of but 2-ene 1,4 dioic acid. Clear, student? So this is a small video of stereoisomerism. This is not full explanation of stereoisomerism. This is only cis trans isomerism, and then after the next topic is a EZ isomerism of geometrical isomerism. Clear? Okay, student? Okay.